right, class, we're going to look at trig functions today. And how to get exact answers without using the calculator. I know you will be using calculator, but this is, you have to understand this step to go into the next part of it, where if you don't understand how to use the exact answer, you won't be able to get the bigger picture when you have to do sum and difference formula and so on. So let's talk about the sixth trig function. Sine, cosine, tangent, and then the reciprocal of them would be cosecant, secant, cotangent. So what we're going to do is we're going to use this SOHCAHTOA. That's sine. Sine of theta equals opposite over hypotenuse. That's the O. K is the cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. So what am I talking about, this theta, opposite, and all that? In order to understand it, we have to look at it in terms of right triangle. And if I name this angle theta, in respect to this angle theta, this would be the opposite side. This would be the adjacent side. This can be also the adjacent side too, but we know this side is also special because this is the hypotenuse. So now we could understand in respect to the sine of theta, if I say sine of theta in using this triangle, I could find out this is opposite over adjacent. I mean opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. So let's say I change this and I make it 3, 4, 5. And I want to know what is sine of theta, cosine of theta, and tangent of theta. And it's very simple. So according to this angle, opposite would be 4 over hypotenuse, which is 5. Cosine would be adjacent over hypotenuse. And this would be opposite over adjacent. Now, do you remember I said that these are the reciprocal of those sine? So what if I ask you what is cosecant of theta? Let me write it next to each other so that way you can see it. Cosecant of theta, that would be 5 over 4. Secant of theta, that would be 5 over 3. Cotangent of theta, that would be 3 over 4. It's that simple. So if I give you a point right at this point, let's call it -1/2. and 3 over 2. And what I'm going to do, I'm going to call that angle T. I want to know sine of T, cosine of T, tangent of T. So you got to ask yourself first, given that this is X and Y, what are the lengths of those stuff over here on the side? What are the length of them? So negative 1/2, that's the X value. The Y value would be 3 over 2. How do you find the length of this side? That one is very simple. A squared plus B squared equals C squared. Pythagorean theorem. So plus in the square root of 3 over 2 square. When you square them and then you add them, you get 4 over 4, which is 1. So this length is 1. So we can go back and finish this problem. So sine of T would be square root of 3 over 2 over 1, which is just square root of 3 over 2. Guys, those of you who are watching this, you could watch the, just in case if you missed it, you could watch this video later on your own time. So cosine of T would be adjacent over hypotenuse, and we know hypotenuse is just 1. Tangent would be opposite over adjacent. So let's simplify that. Quick refresher. It just multiply by its reciprocal. Cancels out, and you get negative square root of 3. Now, what if I ask you to do cosecant of theta, secant of theta, and cotangent of theta? Just reciprocal of that. 2 over square root of 3. I don't care if you rationalize the denominator. Negative 2 over 1, and you get negative 1 over square root of 3. All right, good. Now we're going to look at some special angles. We're going to look at quadrant 1. So the special angles we're going to look at 0, 90 degree. Half of that would be 45 degree. And then we look at that 30 degree. Oops. 60 degree. These are the angles that we'll be looking at. So in order to do that, I'm going to create a table. 0, 30 degree, 45 degree, 60 degree, 90 degree. I'm going to look at sine and cosine. The way I'll go about doing this problem, I'll start at 0, 1, 2, 3, 4, then go bottom 0, 1, 2, 3, 4. Then I'll take square root for all of them. Then I divide everything by 2. As you can see, when we simplify that, this just becomes 1. Square root of 1 over square root of 1 is 1, so this is just 1/2. Square root of 4, which is 2. 2 over 2 is 1. We just repeat this at the bottom. Why are we looking at this? Because if I'm asking what is sine of 30 degree, if you use your calculator, it will give you 0.5 or 1/2. But now you use this table to figure this out. What's happening? So let's look at it. Sine of 30 degree is 1/2. Cosine of 30 degree is square root of 3/2. Sine of 45 degree is square root of 2/2. Cosine of 45 degree is square root of 2/2. All right. Another property that I need to give you, tangent of theta also equals sine of theta over cosine of theta. If I use that property, I could make this table a little bit bigger. Right over here, tangent of theta would be sine of theta over cosine of theta, which is 0/1. I get 1/2 over square root of 3/2, square root of 2/2 over square root of 2/2. I get square root of 3/2 divided by 1/2, and I get 1/0. Right over here, we could simplify some of this. This becomes just 0. This, you cannot divide anything by 0, so therefore this is undefined. We could simplify that. Cancels out, and you get 1 over square root of 3. Oh, this just becomes 1. And cancels out, and you just get square root of 3. So that's our full table, all right? Now, using this table, what we're going to do next, I'm going to give you one more concept. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. All student takes classes. These are very important. The reason I say that, all trig functions are positive here in quadrant 1. Over here, only sine is positive here. Over here, tangent is positive. Over here, only cosine is positive here. Well, also the reciprocal of them are going to be positive too. Why is that important? Because we're going to do problem like, let's say, sine of 120 or cosine of 120. How do we get the exact answer for that? Like, how do we get cosine of 120? I want to know the exact answer for that. How do we go about doing that? Well, in order to do that, we got to do one more thing. Reference angle. Reference angle is basically an angle where the terminal side is the closest to the x-axis. This is very important, x-axis. So for example, let's go to that 120 degree. So that's the original angle, 120 degree. And I use this bar symbol to refer that's the reference angle. So what's the reference angle for 120 degree? So we got to ask ourselves, here's the terminal side. given this terminal side, terminal side is closest to the x-axis, the angle you create. The angle you create where it's closest to the x-axis. Let me I'll write that. The angle you create. So I'm not looking at this y-axis. This is y-axis, not good. I have to look at this angle right over here. So given the whole thing is 120, so whole thing is 180, and the theta is 120, what's the reference angle? So 180 minus 120, you get 60 degree. So the reference angle is 60 degree in this case. Let's do another problem. That was kind of easy. Let's do $260 degrees. 260 degrees. So what would be the reference angle? Now, again, most of you are going to look at it in the y-axis. No. You have to figure out closest to the x-axis, which is this line right over here. So what's the measurement of this angle? Well, again, we know this thing is 180, but we don't subtract 180, 260. We don't do that. Now, because I want to know this angle and 260 is bigger than that, I have to subtract it. When I subtract that, is that Russian? Is that a question? I don't understand that what you wrote. So when you subtract it, that's 80 degrees. So in this case, the reference angle is 80 degrees. Okay? All right. So why is the reference angle important? So if I use cosine of 120, I want to know the exact answer. Well, I can't use the table right now. I can't use this table right over here because the table doesn't have any one of this special angles. But let me find out the reference angle for that. What's the reference angle? For 120 is 60 degree, remember? Well, now I could use the table, and cosine of 60 is what? 1/2. I know that, that's 1/2. But I'm not done yet. The reason I'm not done yet, we got to use this concept right over here. So in the second quadrant, only sine is positive. So therefore, cosine and tangent are going to be negative. So therefore, right over here, the reference angle gives you 1/2, but cosine of 120 gives you, this is going to be negative. And that's your final answer. That's how we get exact answers. Oh my God. Why am I sneezing? Those of you who are using calculator, make sure you know how to use a calculator in terms of radian or degrees. Oh, why am I sneezing? Oh, good God. If you're using degrees, make sure your calculator is in degree. If it's in radian, it's radian. Oh, I forgot to do one more thing. Convert these angles into radian. 0, pi over 6. Oh. Pi over 4. Pi over 3. Oh man, why am I sneezing? and pi over 2. Let's do another problem. Oh, okay. Let me clean my nose. Well, let me give you another problem. Tangent of 315 degree. Try that. Alrighty then. Let's try that. 315 degree is in the fourth quadrant. We got to figure out measurement of this angle close to the x-axis. So the way we go about doing that, 360 minus 315, you get 45 degree. So tangent of 45 degree. Then you got to ask yourself, is tangent positive or negative in this quadrant? Tangent is negative, so you're going to put negative right over here. And if we use the table right above here, tangent of 45 degree, which is 1. So you get negative 1. All right, so this is my end of lecture today. If you have questions, what I did is I extended the homework. Those were due last week. I'm doing it only this time. I'm not gonna extend it anymore. Please do not email me about extensions. I'll see you guys on Thursday.